For all the design patterns that we still have to cover for this course, they all depend on advanced topics related to inheritance, namely polymorphism and dynamic binding. So before we actually start covering them, I would like to do a thorough review on the inheritance, which you learned possibly in your previous OOP course. I'm not going to assume anything, but I just want to do a thorough review with you. So if you got some loosened background from before, please, now you will be the time to pick up the subjects. Let's first of all take a look at the learning objectives. It's quite a big lecture, specifically for the inheritance. So I'm not going to cover everything in this week number 6. Instead, I'm going to break it down into this week. We only talk about just about how you can reuse the code using inheritance, and then next week we'll get to the more sophisticated subjects about polymorphism and dynamic binding. Okay, so we have to first go over designs which do not use inheritance, in which case we're going to criticize about them using maybe cohesion and single choice principle that we learned before. So that's also a very important technique for you to have as a designer. So you also always have to judge for all the alternative solutions, what are the pros and cons for them. And number 2, we'll try to talk about using inheritance just for the code reuse, how we can really minimize code duplicates using inheritance by sharing the code in the subclasses which they inherit from their parent classes. And we'll talk about static type and also polymorphism. We'll talk about dynamic types and also dynamic binding. So these are the concepts that will be reused many times for the design patterns that we talk about. And then we'll talk about typecasting. And then we talk about polymorphism and dynamic binding in a more advanced context, especially how do you really make sense of them in the context of routine arguments, return values, and also so-called polymorphic collections. So this polymorphic collection idea also comes up for all the design patterns that we're going to talk about later. And finally, we'll revisit the ideas about generics. But now this time, rather than thinking more about the single choice principle point of view, which we talked about previously, now we more want to think from the typecasting point of view. So it's a different angle to really revisit the concept. Okay, first of all, let me start with by saying the big picture for the inheritance. So the number one, the most superficial purpose for using inheritance is for code reuse. And then the second one is actually more in-depth understanding about inheritance called the substitutability principle, which you may also have heard of in the previous OOP course. And that one there is really where the basis are for polymorphism and dynamic binding. So that will be definitely something we would like to review. And then also going to talk about compile time checks versus runtime violation. Okay, and then another aspect which I'm pretty sure you haven't heard before in the previous course. So now that in this course we talk about design by contracts, we really want to know what would be the effects of the parents' contracts when they got inherited to their child classes or descendant classes in a more general case. So that's something to do with subcontracting. So we wouldn't really talk about this topic until almost towards the end of the course. We'll get there eventually. Okay, so that one will be also about runtime behavior for checking the contract as inherited from your parent classes. To start with, I would like to talk about a motivating example which we're going to use throughout the lecture this week and next week. There will be 2 running examples. One will be the student management system, which I'm going to present to you now. There will be another one which I'll introduce next week, which will be our smartphone inheritance hierarchy. We'll get there next week. Okay, so I would suggest you pause the video now and then read through this description here for the problem. Okay, that's about the problem here, just one single slide. Read it through and then make sure you understand all the details that's indicated in the requirements over here. And then a little exercise for you for design. Here, the task would be design classes that will satisfy the above problem statements, and at the runtime, you want to make sure each type of students must be able to register a course and also calculate their tuition fee. Okay, and also you will be able to build a student management system. I also made available a handouts for your purpose over here. Okay, just more guidance. Okay, you can download it from the lectures page. So that's the same problem description over here. And then the task will be just what I said. And then requirements will be you want to make sure you have a student management system and that will store a collection of students, and to make sure you can also store a mixed kind of students. Okay, as you read through the problem description, you will see what I mean. And then you want to make sure the student can register and also calculate the tuition fee. Finally, when you are designing your classes, I would suggest also think about cohesion and think about single choice principle. Okay, so that will be your exercise over here. But now I have one little constraint for you. I can tell you that the ultimate solution to this problem over here is by using inheritance. That will be the most elegant solution. But now here's my challenge to you. How would you do it without inheritance? So that's the really the key exercise that what we want to do before we introduce inheritance. We really want to appreciate the power that the inheritance can give to us. So your task will be think about the classes without using inheritance, and then once you get your solution, criticize on that, especially with respect to maybe either cohesion or single choice principle. That'll be the little exercise you want to do. Okay, so hopefully you spend some time thinking about your design of classes to solve this problem here. I plan to actually present to you 2 common design attempts without using inheritance. But before I do that, I would like to just give you some general guiding principle. Let's say you're given some informal description like what you see in the slides, how you're supposed to work out the classes and also routines from there. So this could be useful, especially when you're doing the ETF projects, because you're supposed to come up with the classes yourself. So let me just switch to this proper description over here. So the general principle, as you may have heard in the previous course, whenever you see any nouns, you can turn them into either classes, attributes, or accessors. Accessors really like queries. And for verbs over there, you can turn them into mutators or commands. So this approach over here, of course, is not specific to IFO. So any OOP that you might use, you can definitely apply this guiding principle here. Okay, so let me just tell you how you can apply them in this particular example here. Let's talk about the nouns. So what about classes? Apparently, student management system can be a class. Also, you got resident students, and also you got non-resident students, and also you got do we have any other classes? For example, you wouldn't want to make the name as a class, even though you could, as we learned in the previous birthday book example. But let's say for now, name will just be a string. Okay, so name does not have to be a class in this particular example. Okay, so that'll be for the classes. What about for attributes? So we can say maybe the name for every kind of student will be attributes, and also the register courses that can also be an attributes. Also the discount rate for the non-resident students, and also the premium rate for the resident student, that can also be an attribute, right? Where to put them, we're going to see in the design attempt in a moment. Okay, and then what about accessors over here? Accessor will be, let me use his, well, queries. So here would be, for example, if you want to calculate the tuition, you can think about the tuition itself. It's going to be a query which involves some computation to really return to you the result. And that'll be it. Okay, so finally, we can think about what about mutators. In that case, register. If you want to register for a particular course, that's actually how you can actually add a student into the array or a linked list. So that will be a command or a mutator. Okay, so that's about a very quick suggestion about how you can turn this informal description over here by identifying all the relevant nouns and verbs. Of course, not necessarily every noun and every verb should be turned into a class or some entity in your design. Not necessarily. You have to judge which one you want to take and which one you want to drop. Okay, so that's about the this running example here. And then starting from the next video, I'll actually start talking about 2 different design attempts without using inheritance.